Hi YouTubers, about a year ago I bought this exhaust fan and everything was okay until a few days ago I found that it was not doing his job anymore. And you know, I dismantled the unit because one of the behavior, this is the motor for that fan, one of the behavior that I put this tape so you can see easy when it's turning, and going back, one of the behavior of the problem was that anytime I power up, it kind of jam the shaft. I mean, you can use a plier, try to move it, and it didn't turn at all. So I thought that were the bearings, so I took like a screwdriver, the back of it, snap here until I pulled this cap out and check the bearing. They were perfect. I oiled it. I mean, this is not something that I leave it through a year without oiling the bearing, so it was take care of it. Now the issue was, which is very weird, was that anytime I power up, it gets stuck. Very hard to turn. It's like you cannot turn it, you know. And doing some searching, some reading, most people say, well, it was a bearing problem. Actually, it was not sort of like a bearing problem. It was a kind of a curveball here, because I couldn't understand, because when there's no power, when you don't apply to power to the motor, it turns easily, very gentle, like I'm showing you right now. As soon as you put power into it, it binds so hard into the shaft that you cannot turn it. So I start wondering what was the problem, what might be the problem. And before moving into that, this is what I decided to do. Let's be sure that I understand first of all how an induction motor operates, and as simple as this one, and then take some measurements of the coils to see if any of them is open, or if there is any problem perhaps with the running capacitor that I have it right here. So with that in mind, let me show you how this in particular induction motor is put together. Let me do that. Put a piece of paper here. Basically what you have is, I'm gonna make it very simple. Let's see if I can get my drawing here. What you really have is a coil. Let me do a coil like this, and from that coil you move down and you move this way. Good. And now let me put together what is called, let's call this the main coil, and now let's put together what I call a secondary coil, but this goes through that running capacitor. As you can see, a running capacitor it's not like an electrolytic capacitor, so there's no negative or positive the way this running capacitor works. So here we have our run capacitor, and here is the power, or the power cord for your AC. Right here, an AC source, and that's it. That's how it goes. So the question is, will this circuit open, or this is open? So because it gets stuck, I mean, the issue was that this gets so hard to turn that was impossible. That behavior is also happen when you don't have, like right now, I don't have the capacitor right here. So I pull the capacitor out because I was able to find out what was the problem, and it had to do This type of motor has a lot of, I would say, this movement, and that movement might misalign a little bit the force field or the magnetic field with the, in this case, let me draw it, the square cage, right here, something like this. So this is the shaft. So the problem is it gets some misalignment, and when that happens, it binds so hard to the bearings that it's impossible to move these, even when this is oiled. So when the bearings are okay, you might still have that problem of binding so hard that they're very hard to turn. So I have to accommodate some of the spacers, and still these have a lot of play. That's bad. Now let me bring you a new motor so you know what I'm talking about. This is a new one. This is a better brand. This is a Dayton. Let's see if we can see all the information on this sucker. Good enough. It's a exhaust fan motor, model 41N LO2, 60 Hertz, and 115 volt, one phase, 1/25 horsepower. And so this, I bought this to do another job, and I thought that was ready to be used on this exhaust fan, but I was finally was able to fix the problem, and going back to it, it has still a lot of play that I have to reduce somehow.
We interrupt our program to bring you this important message.
Oops, I forgot. I was about to tell you how much play this is the old motor. Let's see if I can put this. Let's see. This is the Dayton, the new one. I'll put it this way. So, and this is the old one. See how much play this shaft has. It moves up and down a lot. Now the new one is right here. It barely moves the back and forth. So that's what I was saying. There's a big difference between this Dayton and they are both Chinese at the end. I mean, so, but this is how much play it has. So I was able to fix some of that, but you know, I don't know how long will this work. So, but so far, I mean, no matter way, if I put it here, you know, totally this way, it still spins good. If I put it down, it still spins good, and that's good. That's basically the idea. It worked perfect. So, but the new one don't move at all. See, there's no play, and that's very tight. So that's how it goes. Let's see. Going back to the old one, it has the capacitor installed already on this part of the video. If I connect it, it's ready to go. I'm gonna connect it and show you that even with this amount of play, it still works fine. Again, I'm coming from the future. I just want to add this to ensure that you know how much play is more than enough. And I believe that this has plenty of play. That shouldn't be like that, but that was the way the cookie crumbled. Now back to your regular video. Bye. So let me do some power here. Let me put some power. Let me put some tape, some electrical tape to those so they don't touch anything. You hear a little bit of noise. It's raining on my jack here, So, all right, there we go. So let's, emulate what was happening, what was the problem on my motor that was not turning, so you can tell quickly what was the problem. Let me power up. I'm going to power up. You see, right now, there we go. That was not happening. So in other words, as you can see, I didn't have the running capacitor installed, but it works. So, but you need to push it. That was not the case. It was impossible to make it run. Meaning that I put enough washer here, enough spacer to reduce this movement. This up and down movement was crazy at the beginning. So, and that was causing all the trouble. So, again, as you can see, you can turn it on. I mean, I'm gonna hit power now again. It's not turning, but as soon as I apply a little bit of turning speed, it keeps going, and that's what you want. Now, let's put now the capacitor. Actually, I'm gonna check that for you, just to be sure that the capacitor is, let's see if I can get a good, yeah, 5 microfarad. That will do. Excellent. Turn it off. So as you can see, it was easy to solve the issue, because the issue was on this vertical movement that was creating a misalignment between the shaft and the square cage and the body, like something like this. So there was too much movement. Like for example, this is an very old that I have it here for demonstration. So the problem was that it was getting misaligned on this direction somehow, but the idea is to have it right where you want it. So there's rotation that can be transmitted, and you don't have any trouble with that. So that was basically the problem. Now, again, what we're gonna do is check the value for both. I know that they work already now, because I'm gonna check the resistance value of both coils. Because if one set that is kind of open, that means that is really damaged, that side of the coil, and obviously will not work. If the main coil is bad, no matter how much I turn this guy, it will never work. If the run capacitor is bad, as you can see, just by turning with your hand, probably it will work. It might work, you see. But again, it's not stuck. You have to ensure that it turns easily with your hands. You put it like this way. I put it this very, pulling this way totally out. I turn it, no problem. Turn it down, no problem. No matter where I put the guy, it turns. And that's important, because if you put it like this and then you feel like it's binding, you have a problem. It cannot bind to anything. It have to be totally loose. Alright, so now going back to measuring the resistance value. So here's the power cord. This unit comes without it, so I have to dismantle a little bit this to get into it. But anyway, I'm still can do what I need to do. Like for example, here is my AC cord. If you follow the regular convention, let's see. In a regular convention, this one here, this one will be the white, and this one will be the hot. Let me be sure, yeah. So the way you're watching this now, you see they're the same side. That's why I'm confused. Some of the white one tends to be larger, and this one, the hot one, the black one, to be smaller. And but since this has a ground on it, meaning that this one is the white one and this one is the hot one. So no matter what, I mean, get a resistance meter, anything that you can use to make it. And let's put this guy into select, there we go. I can measure it. This meter is kind of nice. This is a very handy Craftsman. It can also measure capacitance. So let's see. Yeah, right there. Let's see it a bit closer. You can see it can measure ohms, capacitance, diodes, and continuity. All right, that's this bit here. So with that said, let's start by measuring resistance. Yeah, now let's see if it works. Let me get closer. To the both. I'm connecting both together just to see that I got the 0. Perfect. So now let me move a little bit back so that you get the whole picture of what I'm doing for checking the. So right now I'm using one of the side. All right. In fact, if I do like this, see, right now, if I'm checking the hot and the white and the what is called the neutral. You see, the hot and the neutral. Between the hot and the neutral, for this motor, you are getting a reading of about 59 ohms. So I would say put a 59 ohms right here on this coil. 59 ohms right there. Now the question, the question is, if you get it, obviously, if you get something different, like way too high, you know that you have an open circuit, and that would be bad. And you will never see my motor turning the way it did. So now let's check the one with the wrong capacitor. Now here's the story. The wrong capacitor, you need to identify where you are measuring it. Like for example, you are measuring from here, or because if you measure from here, you put one of the cables, the measurement cable, in here, is basically the same that I have right now. So depending on which of the two cables you can measure here, that would be equivalent to what I did already, and you will be measuring the main coil. If you want to measure this one, the auxiliary coil, let's call this the auxiliary coil. If you want to measure the auxiliary coil, then you have to be above the capacitor. So now the question, how I will do that? Oh, simple. Get back to your capacitor, where your capacitor was located. Now pull this cable out, and now let's figure it out which one with a continuity meter will do the trick. Let's say if I put these, let me pull this out a little bit more actually. If I put this on continuity, here we go. It's ringing very light. You can't even not listen to it, but let me see. Yeah. Actually, I'm checking here. Alright. This guy seems to be the auxiliary one. Now, how I know that? It's a totally different resistance value. Like for example, I'm having this, I'm going through this one here, I'm going through the hot side, this is the hot side, and from the hot, again, if I measure here, I got about the 59 or so, 59. Now, if I measure This side, let's see if I got the 59 again. See? Got the 59. Yeah, I will do. So that's the 15. You don't want to be on this side of the capacitor. You want to be on the other side of the capacitor, which is this one. Now when I measured that one, I got about 97. Yep, that's about 97. That's it. 97. So the auxiliary here is 97 ohms. So I can certainly do a check on this one. This is the new one. Let me do a quick check on the new one, at least without, well, I can certainly pull the capacitor and find out how close these values on this old motor are compared to my nice Dayton motor, just for comparison. Okay. It's hard to see the label on this guy. Let's see, because I got ready, bang it. Oh, I guess you can. This is the old one. You can still see some of it right through there. So it's what they call it, a PSC80-422. Pretty much the same label as the new one, and so let me check this one. I want to open this and find out and what we got. Let me open this. Now, in one side will be the capacitor, the other side will be the power cord. So which one you have it is right here. This is the ground cable. So here you have to have, here's where the power cord is going to be connected. So let's get this bolt out. And we can quickly check whether the value that I'm reading on my old unit are comparable to the new unit. Different brand, different everything, but let's see, there's something here. It's kind of nice sometimes to take a look at it. Not a big deal. You want to put a speed control, otherwise they will spin at their full power, which is basically what I use. So let me get the cables out. There we go. Here we go. Here we go. The guy. So let's check the values and find out whether they looks pretty much. Let's see. Checking out the yeah. How about that, huh? Right at the body. 59. This is the new unit. 59 ohms. The main coil. 59 ohms. About 58. You can see a 58. About 1 ohm less, but not a big deal. Good. Now checking to the other, I will have to pull. Should I do that? Let me see. Let me open the capacitor. I hate to, to mess with something that is already working fine. But find out. Yeah, where's the bird? Where's the baby? It's right here. Look, let's see what's this guy. Yeah, 5 microfarad. And I like the way cable. Let's see if I can really pinch. Maybe I can certainly do that. Let's see. Okay, it's gonna be hard. Let's see. Trying to. There we go. Doing it right. Let me see. Yep. I'm measuring between the capacitor, meaning that I will be, this reading 154 must be the sum of this coil and this coil, because basically I have one leg here and another leg here, and so just to be sure I'm doing this right, let me pull that one there from there, and let me see if I'm above the capacitor. Let's see where I'm going to be reading. Let's check this. $155. Let's check the other one. Yeah, this is the running capacitor. I mean the coil, the auxiliary coil. That will add up right. So that's about 96. The running coil. About 96 the running coil. About 58 the main coil. Just perfect. Obviously, this is a brand new one. I don't have to mess too much with it, so I can put it back. Put it back the way it was, so it looks good. There we go. Put the put this back here. Remember, this is the new one. I bought it for another project, and so it's kind of interesting for the comparison. They are pretty much identical. The other motor, the one that comes with the exhaust fan equipment, I couldn't get the replacement, the identical replacement. But doing some research, found that this motor again can be replaced with the one that I show you. So that's good to know, and that's where we are right now. Alright, this is perfect. So what is left is take my old motor, now that I fixed the proper position of it, get the running capacitor installed. But before doing that, how about if I check the capacitor? Alright, here's the capacitor. So probably running out of time with my recording equipment here, so let's see. Let me put this on. Nanofarad. There we go. Now let's get one of the leg here and the other leg down here, and let's check the meter. 4.6 microfarad. That's right at the money, no problem there. So let's install it and let's see what happens. Running out of time on my recorder here, so let's do this quick just for a testing before it's over, which is gonna be very soon. Let's connect the power and let's see what happens. I think that I'm less than a minute or so getting the power. Oops, I think it's over. No, not yet. Let me turn it on. There we go. Perfect. See, now it's turning with the capacitor installed, so it really turned. No more problem. All right, so here we are. This is kind of a summary of the work that we did. As I said, I have one of these iLIVING exhaust fan, and I bought this about a year ago, and it fell, and that's what I start to see what was the problem, and the issue was the motor. Obviously, it didn't turn what that was supposed to do. So right here, I'm showing you what an induction motor looks like. It's the simple one with a one phase, 120 volts, and that it has an auxiliary winding coil and the main coil, and the square cage rotor, and it also has the capacitor. It's a running capacitor, and embedded here is the thermal fuse, which is not shown. So the troubleshooting that I did was very simple. I went through, let's see if I can get this to work. Maybe not there, maybe here. A little bit more. Here we go. So these are typical problems for these simple motors, induction motor. Like for example, auxiliary coil open, you have an open circuit. So one quick check to do this is you remove the capacitor and check the resistance reading between the capacitor terminal. It should have a value above the main coil. We'll see that in a second, but never an open circuit. If you read an open circuit, you have a problem. Like for example, this value here on my motor was about 156 ohms, meaning that is reading both. If you do this, so you, like for example, put one of your terminals right here on this point here, uh, and you take a reading somewhere here, basically here above the capacitor, you will be reading this is coming down here. It will read the second coil, and eventually will hit it right here. So you are adding both coil, the resistance value together. So eventually you're gonna get this result of 156, meaning that the auxiliary coil is about 97. You can measure this by the totally alone. So, but I'm just saying. Now for the main coil is extremely straightforward, because basically you just needs to do your meter reading right from the terminals of the AC main, and that will tell you if there's an open circuit here or if there's an open circuit here as well, as I just show you, and so forth. So going back here, so those are the way you to ensure that definitely you don't have an open coil circuit. How about if I have a short circuit? Well, that's gonna take a little bit more of thinking about it. In case of a short circuit, that's bad just to start with. You shouldn't have a short circuit, because basically you are talking, like for example, too much current might go through, creating a fire hazard or something like that. So that's bad to start with, having a short circuit. Now a bad bearing. Here I was chasing a wild goose for a while, because I know that my coil were okay. So the auxiliary coil was okay and the main coil was okay, but Here was the issue. I greased properly. I made sure the rotor turned freely, no problem. Push the shaft in and out, and that's when I discovered that there was too much play in the in and out of the rotor, so it might get misaligned with the stator field or magnetic field. So here what happened. The motor appeared to rotate freely without power. However, when it was powered, the rotor got stuck. Several additional washers were located on the rotor to prevent the up and down movement of the rotor, to prevent at least a little bit, because it still has a lot. But it did the trick. So now the rotor turned properly. I don't see more of an issue here. But definitely, I start to investigate this more when I realized that the coil were okay. I said, then, I mean, the only thing, either is a bad bearing or a bad capacitor, because not even a bad thermal fuse. So let me keep the order here. Bad capacitor, if the engine does not, I mean the engine, I will say here, let me change this. If the motor, if the motor does not start, but start to rotate normally when push it. You push it with your hand and it works. Probably most likely you have a faulty capacitor. However, in our case, the capacitor was fine with a final reading of 4.6 microfarad. Even the capacitor has the name. Plate says something about 5 microfarad, so no big deal there. How about a bad thermal fuse? Wow, this could be a problem all by its own. In fact, there's two aspects to this. If the thermal fuse is blown out, you will see an infinite resistance, so like an open circuit, something like going back to here. And so if it's the thermal fuse, you might do a couple of things. Let's check this. It says, check if the fuse can be replaced without damaging the coil. If the motor start but it stopped quickly, this is the second part, and the bearings are okay, you probably have a bad thermal fuse. And you can check this again with a heat gun. You heat it a little bit and see whether the problem show up again. You might be again chasing a wild goose here with the thermal fuse. Sometimes just you replace it and with a good one. If it work, it work. If it not, then you have another problem. In my case, since it didn't show open circuit, so I never thought about that I have a bad thermal fuse. But let me tell you something. If it just happened that it's a bad thermal fuse, we are in trouble, because this motor, where the thermal fuse was located, was bad as it can be. For example, let's check this out. If you have a thermal fuse like this, well above the coils, then no problem. You are okay. You can replace this anytime. Easy. Now, you have a thermal fuse like this, kind of glued to the coil. Maybe it's still easy that can be replaced. Maybe. I'm just saying maybe. However, my case was more like this. In fact, even worse than this. Unfortunately, I didn't take a picture of it. But it's worse because the coil is going above of it, and it's really deep in within the coil of the starter. What that means is, if it's bad, you just toss the motor out. There's no, I mean, trying to remove it is just crazy. There's no point to do that. So again, depending on where the thermal fuse is located, chances are that you might be able to remove it in case it's bad. Otherwise, just toss the motor out and get a new one, and you are in business back again. Again, those are, I would say, in general, my rule of thumb to investigate problem. If the coils are okay, most I would say the culprit of the problem might be bad bearings, but in such a way that this was kind of funny, because when the motor was not powered, it rotated freely, but when the motor was powered, it got stuck heavily. You cannot even move it with pliers or anything. It was like a very strong magnetic force was holding the rotor. Eventually, that's when I start to mess around with the rotor location. You know, in and out position, and that's what I start to see, that it depending of how deep was within the starter, it will rotate or it will not. So I said, might be some misaligning in the rotor position with respect to the starter of the motor. Anyway, that's basically it. I hope that this helped you in your induction fan motors. As I always said, be safe, whatever be your final destination. Thank you. Have a great day.